and then I'll post this recording after, but excuse me. So yeah, matrix form, you can see all these now in the recording that it's just the numbers, make sure the negatives, no comma or anything like that. So 6 would be 4, 3. Who's got 7?
-7 and 2.
Yep. And 8.
-7, -6.
Perfect. And 9. I'll take it 2, 8. But like I said, each one of these can be represented in a lot of different ways. The way that you see. My Alexa just went off for no reason. With the actual diagram of it on a coordinate plane, with the brackets around it, or in matrix form. All right, and then it talked about adding and subtracting them. And it's just like adding X's and Y's, just keep with the same. Like I was saying in the thing, if you're doing matrix A plus matrix B, matrix A would start and go 3, 4. The matrix A would go up here. And then to add B, you would start B where it ends and go -6, +2. So it'd go back in that direction. And then the result of that is from the very start to the very end. That's the resulting or the sum of those matrices. But it's as simple as taking A, 3i and 4j, and adding B, -6i and 2j, and just adding the parts. So it'd be -3i plus 6j would be the resulting matrix. Anybody want to do E plus D? So E is 9i minus 6j. D is -7i minus 3j. So what would the results be? Go ahead.
2 and -9.
2i minus 9j. Right. Perfect. Yep. B plus H. B is -6i plus 2j. H is 5i minus 1j. So what would that one be? Who's got that one? -1i.
Oh, and then it'd be positive I net 1j.
Right. Right. You don't need the -1 there. Oh, my thing froze. There it is. You don't need the -1. You could just write -i plus j for that one. Perfect. Subtracting them is like F goes over 7 and up 3. But if I'm going to subtract A, what I'm really doing is taking matrix F and adding the opposite of matrix A. And the opposite of a matrix is just take the matrix and make it point in the opposite direction. So that would be -3, -3, -4. So go like down like that. And then the resulting matrix is still start to end. So if F is 7i plus 3j, and you're going to add the opposite of A, which is -3i minus 4j, then you would get 4i minus 1j. Anybody want to try C minus G? It'll be 6i minus j plus the opposite of G would be -1i plus 5j. So the results would be
5i plus 4j.
correct. Yeah. E minus F would be the E, 9I minus 6J. And minus F would be negative 7I minus 3J. Dabby, you got that one? How about Steph's not here. Sony, you got this one? All right, let's go. Zoe, you got this one?
2I minus 9J.
So good. Thank you, Zoe. Perfect. All right, so adding, subtracting, pretty straightforward. When you do the scalar multiplication, if it'll switch. So yesterday at 2:05, I tell you guys I'm on here till nobody's tested me yet, till 2:10. But at 2:05, Mr. Stallsworth showed up for a class walkthrough. I'm like, you missed them. They've been long gone. He said he'd be back today, but I haven't seen him. It's never going to change pages. Oh, there it is. Okay, so like for F, if matrix F is 7 plus 3, so it's over 7 and up 3, then 4F is like having 4 of those in a row. So those 4 matrices, then the resulting matrix is the whole thing. But you can just multiply 4 times each part, each component. So 4 times 7 would be 28I, 4 times 3, 12J. Half of a matrix would be the same thing if B is negative 6 plus 2. Sorry. If that's B, then cut it in half, and that's half the matrix, which would be negative 3 plus 1, if you just take half of it. Negative 3 means make it go in the opposite direction, and then 3 times. So it'd be like 3C is 6 minus 1. So if you did 3 of them, and then the opposite of that, that'd be a negative 18I plus 3J. And then negative 2/3, we talked about multiplying with fractions with E. Is it here? Remember, if they're multiples of 3, you can divide first and then multiply by 2. So 9 divided by 3 is 3. 3 times 2 is 6, and then negative. So that'd be a negative 6I. 6 divided by 3 is 2, times 2 is 4. And then 2 negatives make a positive 4J. D plus F, those are opposite matrix. So when you add two opposite matrix, you get 0. It would be all right just to write 0. In vector form, you would write 0, 0. Or in that form, you'd write that 0, 0. Almost looks like a face. So for you wouldn't put a smiley face with it, but that's what you do it. All right, and finally, this 5A minus 3G would be the 5A. That's 15I and 20J. And then you would add the opposite of 3G. So that'd be negative 3I, positive 15J, excuse me, 12I, 35J. Let me mute for. Sorry, I had to clear my throat. Okay, so hopefully you get those all right. Last part are these word problems. Now, we haven't talked about matrices have direction and magnitude. on your test, you have a question about magnitude, and magnitude is, I'll show you on these, it's pretty simple. Same formula every time. The important part on these is what is the resulting vector? When you see resulting vector, that's the two added together. So the speed and direction of a boat, there's the boat. So you have this boat that's going this direction. You have a current of -18, +12. So you got the current that's actually pushing it this direction. And so this resulting matrix is where the boat is actually going. So you take 56I minus 33J, you're adding the -18I plus 12J, and you end up with 56 minus 18 would be 38I minus 21J. So that's the resulting vector of the boat within the current. Now the magnitude where it says what's the speed of the boat, and this should say like miles per hour or feet per second or whatever this, it doesn't tell us what the measurement is, but it's always the square root of the two components squared and added together. Now in your calculator, when you square a number, if it's negative, it's going to be positive anyhow. So I wouldn't even put that in the calculator. I would just either on Desmos or in your own calculator, it's the square root of 38 squared plus 21 squared, 43.4. So either that's miles per hour or feet per second. I don't know what it is, but that would be the speed. All right, so an airplane is flying along this vector with miles per hour after 3 hours. So it's going 41.7. So it's going like that. But it's also doing that for 3 hours. So this is per hour. So another hour and another hour for 3 hours. Then it turns and goes 38, -15. So it's going down now, this direction. Per hour, what's the plane's result after 5 hours? Well, there's 1 hour, 2 hours, 3 hours, 4. So another one, that would make 5 total hours. So you have 3 of the beginning vector, the first vector, just call it A, plus 2 of that B vector to get the resulting vector. So 3 times 41, 123I plus 3 times 7 would be 21J. 2 of these would be 76I minus 30J. So the results are 123 plus 76, 199I minus 9J. So that's the direction it's going in. And then how far, this is in distance, it's in miles. So the miles would be the 199 squared plus 9 squared. So the square root of 199 squared plus 9 squared is about 199.2 miles. That's it. So be careful about that if it's more than one vector. So to get to a destination, a plane needs the resulting vector to be -837. So it needs to fly from here to here. If the wind is blowing So this plane has to fly if the wind is blowing 2215. So that's the wind is blowing this way. Then where does that plane need to fly to so that the wind is going to blow it onto the course it needs? So remember, it's the plane plus the wind will equal that resulting vector. The plane vector plus the wind will equal the resulting vector. Well, we know the resulting when we know the wind. They want to know what's the plane. So you do the resulting minus the wind, or add the opposite of the wind. So the negative 84 plus 37 I and j, add negative 22i minus 15j, and negative 106i plus, what's that, 12, 37 minus 15, 22j. So it has to fly along that. And what's the speed of that? Again, the square root of 106 squared plus 22 squared. 106 squared. Square root of 106 squared plus 22 squared. 108.3. And again, it should, I didn't write these questions very good because I should say miles per hour. All right, so two tugboats are pushing an ocean liner. So there's this ocean liner. Tugboat one is pushing negative 15, negative 32. So that direction. Tugboat two, negative 3, positive 25. So it's like that direction. And the tugboat itself is going positive 8, positive 10. So it's going in that direction. Well, if you put all of those end to end to end, you would get the resulting of what's going to happen to this tugboat. So if we moved them around, or you're just adding them all together. So you have the tugboat, or I'm sorry, the actual ocean liner. You have the first tugboat, and you have the second tugboat. You just add them all up for the resulting vector. So negative 18 and positive 8 is negative 10. 35 minus 32 is 3. So that's where they're going to be pushing it, what direction they're pushing it into. And the resulting magnitude is 10 squared plus 3 squared. So the square root 10 squared plus 3 squared, 10.4. And that could be a force or a speed, doesn't really say. All right, so this tug of war has 4 ropes with a knot right at the origin. And each team is going to pull into their quadrant. So when time is called, team 1 ends up pulling at 8 plus 5, so they're pulling that direction. Team 2 pulls negative 5 plus 12. Team 3 is negative 6 and negative 9. And then team 4 is pulling at 2 and minus 10. So each one of them pulls into their quadrant, and whoever gets the knot into their quadrant wins. So it's just, again, add them all up. 8i plus 5j negative 5i plus 12j would be 3i plus 17j. The second two, negative 6i minus 9j, 2i minus 10j would give us negative 4i minus 19j. Add that with the other two, add them all together, get negative I minus 2j, so that knot would be team 3 or quadrant 3 is the winner. So which team wins? Quadrant 3. And that didn't say anything about a result, a magnitude, so you just need that final matrix and what quadrant it would be in. All right, so this last one, you have this earth ball. You guys, it's a huge ball that's like on a playground, earth ball. One child is pushing it negative 12 plus 5, so they're going this direction on the earth ball. A second one is pushing it positive 4 plus 3i, so this direction. And we want to know which direction should the third child push to make it remain still. Well, if you add those two together, you get negative 8i plus 8j. So if a third child is going to push to make it stationary, that means you want a 0 outcome. So they would have to do the opposite, plus 8i minus 8j, which is like that way. But that's the answer. What's the force required? Well, that's the magnitude. 8 squared, 8 squared. The square root of 8 squared plus 8 squared is 11.3. Pounds per square inch or whatever the force is. But yeah, it makes sense that they would have to do an equal and opposite force of those two to get the ball to stay put. I think, yep, that's it. So I'm going to stop that recording.